Hello everyone, myself Mohammad Asif Ahmed from CSE IoT branch, Portland. Today I am going to talk about two-phase locking in dbms. But before knowing about two-phase locking in dbms, we should know something to understand it in better way. So let's see. First one is transaction in dbms. Second, concurrency control. Third one is schedules in transaction, and fourth one is locking mechanism. Six, problem without locking. Now, one by one, we will see these 5 points. So, first one is transaction in dbms. So, the definition of transaction in dbms is a transaction is a sequence of operation performed as a single logical unit of work. So, now properties of transaction in dbms. Properties: atomicity, all or nothing. Consistency maintains DB integrity, isolation. Transactions are independent. Durability, once committed, changes persist. Property, it is also known as acid. The short form is acid. A for A stands for atomicity, C for consistency, I for isolation, D for durability. Second point is concurrency control. Why it's needed? To handle multiple transactions executing simultaneously without interfering with each other. It is useful to understand the problem like lost update, dirty read, unpredictable read, phantom read. Now the third point is schedules in transaction. Serial schedules. One transaction at a time, concurrent schedule, multiple transactions interleaved. And the last point is locking mechanism. The second last point is locking mechanism. Lock. A mechanism to control concurrent access to data. There are two types of lock: shared lock for reading, exclusive lock for writing. And the last, problem without locking. Now we will move to the our main topic, which is two-phase locking in dbms. So let's go to the next page. Two-phase locking technique. In database system concurrency, control is the process of managing simultaneous operation without conflicting with each other. When multiple transactions try to access the same data at the same time, there is a risk of errors such as lost updates or inconsistent data. And to prevent this, locking techniques are used. A lock restricts access to a data item, ensuring that one transaction does not interfere with another. This lock helps maintain data integrity and ensure proper execution. So, in simple way we can say that it is used to maintain the integrity and to protect the data from being collapsed. So there are two types of phase locking. So we will see both one by one. So the first one is binary locking technique. It is a two-state locking system, which means each data item has only two possible states, which is logged or unlogged. We do not log one as one or unlocked as zero. The second point is no operation distinction. Binary locking does not. So how can we understand no operation distinction? Binary locking does not differentiate between read and write operation. Both require a lock. Third one is pre-access lock requirement. A transaction must require a lock on a data item before accessing it in any way. And the fourth point is post-access unlocking. After completing the operation, the transaction must release the lock setting it to unlock. And the last point is single transaction control. Only one transaction can access data at a time, even for reading, which means at a time we can access only one data for reading purpose. So the next point is simple and easy to implement. It is very easy to implement. It uses a basic primary binary mechanism. Make it easy to understand and implement in a smaller system. Next point is no shared access. Multiple read operations at the same time are not allowed, even if they don't modify the data. Next point is low concurrency. Due to its strict logging, it offers low concurrency, which can lead to delays in a high traffic environment. And the next point is risk of bottlenecks. Transactions might wait unnecessarily, even when their operation wouldn't cause conflicts. And the last point is rare in modern DBMS. Binary locking is not commonly used in modern systems due to its inflexibility and inefficient resources uses. Now we will move on to the next type of lock, which is shared or exclusive locking technique. So, two type of locks are there. There are shared locks S lock for reading and exclusive locks X locks for writing. So now the second point is allows shared reading. In this, multiple transactions can hold a shared lock simultaneously, allowing concurrent reads of the same data. Exclusive for writing. An exclusive lock ensure only one transaction can write or modify the data. No other transaction can read or write at that time. It means at the time we can only read or write at that time. No other task can be done at the same time. Improve concurrency. So our fourth point is improve concurrency. It means by allowing multiple reads at once, this method is this method increase concurrency compared to binary logging. And the fifth point is conflict prevention. It is the one of the main function of shared exclusive logging technique, which is conflict prevention. It prevents conflicts like lost updates, dirty reads, and uncommitted data access by strictly controlling access. So now we will move it to the next point, which is log compatibility rules. Shared versus shared, compatible. Shared versus exclusive, not compatible. Exclusive versus exclusive, not compatible. So it has some restriction. It is not compatible with everyone. For to be compatibility, it should be shared in same way. Shared versus shared, which is compatible. If you share shared versus exclusive, not compatible. So now the next point is granular control. It provides fine-grained control over data access, distinguishing between harmless reads and critical writes. And the next point is required lock manager. A lock manager or controller is needed to track lock types, resolve conflicts, and manage lock requests, widely used in dbms. The next point is widely used in dbms. Most modern database systems like MySQL, Oracle, SQL servers use this technique due to its balance between safety and performance. The last point is the post-isolation acid. We have already discussed about acid. So this locking technique plays a major role in enforcing the isolation property of acid transaction. So this is the two type of locking: binary and share exclusive blocking. Thank you.